it's going to force you to learn how to enter algebraic strings in math, which is important. What that means is I've got to put in something just like a row of symbols that's going to represent an algebraic expression. You're going to have to do that a lot of times now and later, like when you go to college and stuff, when you're doing computer math stuff there, and you're entering things into a calculator or a computer algebra system. You'll do a lot of this. So let's take a look and see how it works. Now, in this problem, we're supposed to, this is actually an Algebra 2 problem. We're doing some review there also, but it's a good example for us to use. It wants us to take this formula and solve it for p. So I'm just going to isolate p on one side of the equation in terms of all the other variables. Now, it's not really hard. What's the one step I've got to do to get that p by itself? Right now it's being multiplied by the r and the t. How do I undo multiplying by r and t? Yes, sir. Divide. Okay, so I could divide both sides through by rt, and then I'd get the p by itself on one side. Right, now the p's on the right. If I want to make it on the left, that's fine. I could write this as p equals a divided by rt. So all I've got to do in here is I've got to enter that string, but not, I can't pull down a little template that's going to look like a fraction. I've got to just enter it horizontally. So what's that look like? Okay, watch what happens if I put in, I've got p equals, if I put a divided by rt. Now, there's a nice feature here. Notice there are two buttons I can push. I have the check button, which is the same as it's always been. That means I'm going to turn in the problem and see how I did. On homeworks, that's no big deal. If I push check, it's going to tell me I got it wrong, first of all, because I did. But the other thing it's going to do is it's going to, in this little box right here, it's going to tell me what I actually entered as an algebra expression. It's going to turn it into a nice looking algebra expression with exponents and square roots and fractions and stuff like that. But is that really what I wanted? No, it's not. Now on a homework, it's no big deal for me to go back and make the appropriate changes, but on a test, if I had pushed check, I would have lost points on that. Okay, but I could have done this problem without ever hitting check. I could have seen what the computer was interpreting there by pushing the display response button. Let's start over. If I go start again, so if I had put in a divided by rt, or if I want to put a time sign in there to help me see what I'm doing, that's fine. I can put a time sign in there. Either way, watch what happens. When I push display response, I didn't turn it in, so it hasn't graded it, but it's asking me essentially, is that what I wanted? No, it's not. How do I change it? What do you think? Suggestions? Yes, ma'am. Good, we need to put the r and the t in parentheses, because what happened here? Well, the computer just followed order of operations. It took a divided by r and got that fraction, and then it multiplied everything by t. It did what we told it to, but what we really need to do instead is put parentheses around the bottom so the whole thing is being divided by a. Like that, right? That looks better, doesn't it? So now if I hit check, I'm in the money. That's good. See, that worked. Okay? Now, what if I wanted to do something a little different? Like, let's just say that my answer was, well, let's try going down a little bit and see if we get a better one here. Like that guy right there. Okay, what about him? If I want to solve that for h, what do I do to get this h by itself? And this is good review. What's one thing I've got to do to both sides? Let's break this into steps. Step 1. What's one thing I've got to do to isolate that h on the right side of the equation? Suggestions?
Wouldn't you have to times by the reciprocal of 1/3?
I'm going to multiply by 3. Good. I want to get rid of the 1/3. And so I'm going to multiply both sides by 3, right? And that's going to cancel the 1/3, right? Okay, so that's gonna leave me with, if I do that, that's gonna leave me with 3v equals pi r squared h. Okay, what's the second step I've got to do to get that h by itself? What's being done to the h there that I have to undo? Okay, it's being multiplied by pi r squared, isn't it? So how do I undo multiplying by pi r squared? Divide. Divide by that stuff, right? So step 2 would be, I'm going to divide both sides through by pi r squared. And then that's going to cancel the pi and the r squared. And I got the h by itself, right? So I made it. I solved the problem. I get h equals 3v divided by pi r squared. So now how do we input that in this question? Okay, you tell me. So what's the first thing I do? I've got the h by itself on one side. On the other side, how do I say 3v divided by pi r squared? I'll start you off. The 3v is okay like that, but now how do I divide by all that stuff? What do you think? Kind of like the last one we did. Okay, good. I've got to divide by, in parentheses, pi r squared. But notice that it says when you want to enter a pi, you just type in pi for pi. Okay, so I could put in pi, and then I could just put r squared there, or if I want to, so I can kind of see what's going on in here, I could put a time sign to separate the pi. It's up to you. You don't have to. And then I want to put an r squared, but how do you suppose I say squared? What do you think? I could, but there's a way I can actually, that's just going to make it look like r times r. There's a way I can actually make it look like an exponent. What do you think? Yeah, the caret sign. That's the sign for power. And that's a good one for you to know. And that's, in fact, the one that's used on your calculators. So if I want to make something to an exponent, I just do Shift 6. So it's up there right above the letters on the keyboard. And I use that symbol, that caret symbol. Okay. Then if I put a 2 there and close the parentheses, now let's check this. Hey, that looks good, doesn't it? That's what we wanted, right? And so if I hit check, it's going to work.
Yay.
Okay, yay for us. All right. Maybe the only other thing that we haven't covered would be like a square root. Okay, if I want to do, and the answer here is in square root, but let's just pretend the answer was the square root of x. Here's how you do square roots. This is one that's a little bit odd. You got to kind of remember. You put in squirt, SQRT. Whoops. SQRT. And if I put squirt x, look what it does. Oh, hang on. I can't use x because that's not a variable in this problem. I have to use one of these variables. So I'll make it, how about r instead of x? If you use a variable that's not in the problem, it's going to give you that message saying, oh, that's the wrong variable. It's not part of the problem. So, but if I put in squirt r, what it does, it gives me a nice square root, right? Now, what if I want to do the square root of, I want to do this. I want to do, say I want to write the square root of r plus 3. How do you suppose I could put all that stuff inside the square root? What was our way of putting everything in the denominator before? Parentheses, yeah. I could put the square or squirt r plus 3, oops, r plus 3, and that works. Okay, now what if I wanted to put outside of the parentheses, I wanted to put minus 7. What would I do? What do you think? Outside the parentheses. You got it. See how that works? Okay, so I'll admit that's not quite as nice as being able to pull down those little templates. But until I get those other questions working reliably, I just don't want to use them. They're just too much hassle. It's marking people wrong when they're doing things right. It's gonna be such a pain for me to try to fix all that stuff. So we're gonna have to go to these kinds, these older kinds. But it's honestly, you guys will get the hang of this within a day or two. That'll be no big deal for you. Okay. All right. So let's backtrack here and quickly take a look at a couple of practice problems from the linear system stuff. Seems like people were having a little trouble with that. So how about one like this? Solve the system, and they're telling us this time to use substitution. So let me copy that problem down, and we'll do it, and then we'll try and put in the answer. Okay, so what do we do? Talk me through that one. What do we do to solve this? We're using substitution.
You have to plug the x into the x.
Good. Okay, now this one's already half done for us. Maybe not half done, but at least partially done for us. It's already solved for a variable. So let's put a box around this because that's our substitution equation, right? And so we're going to substitute all this stuff for that x, right? What used to be an x, I'm going to trade for a y minus 3. There's my substitution. So we end up then with -2 times all that stuff. Now I have to put it in parentheses because there's more than one thing, right? -2 times y minus 3 plus 5y equals -9. There's my substitution, right? Okay, makes sense? Now what? Now what do we do? Yeah, now we're just going to solve, right? We'll simplify. So I can't yet point at a single variable, so I'm going to have to simplify a bit. If I use my order of operations tree, I'm still doing that, right? I'm going to go down. I can't do anything in parentheses, but I can multiply. I can distribute that -2 all the way through, right? And I get -2y plus 6 plus 5y equals -9. Now what? Okay, well, I can combine like terms, right? I can add up like terms. -2y plus 5y is 3y. Okay, and now I've got my single variable that I can point to, so I can isolate it. I can just go this direction and get that y by itself. What do I do? Add 6? Subtract 6? Okay, so subtract 6, so I get 3y equals, what's -9 minus 6? -15. It's the very same thing. Subtracting is like adding a negative. So -9, perhaps it's easier to think of that as -9 plus -6. Either way, it's -15. And what's my last step?
Divide by 3.
Divide by 3. So y equals -5. Good. Are we done? No, we're halfway there. We got the y value. Now, where does that y value go? Yeah, in fact, I go right back to my substitution equation that I put a box around, where the x is isolated. I'll plug in the value of y, and then I'm just going to get x equals y, which is -5 minus 3. So what's x? -8. So I got the ordered pair then. -8, -5, right? Okay, so let's try that. -8, comma. We said -5, is that what it was? Okay. Did it work? Yeah, it worked. Good. Okay, so we got it. So there's one like that. Now let's take a quick look down at What's the difference between that last problem I did and this one? Say it again. One of them, it hasn't solved for one of them, but that's easy to do, isn't it? Does this one tell me to use substitution? I think it does. Yeah. So what would I have to do to use substitution here? The only extra step we need is what? Yeah, we have to isolate a variable. Well, there's only one variable up there that's easy to isolate. The only one that's easy to isolate is that guy. It's that y, right? So I could get that y by itself by just adding 2x to both sides. So that's going to give me the equation y equals 2x plus 2 or 2 plus 2x, either one. Doesn't matter. So there's my substitution equation, right? And so what's the substitution that I'm going to make?
You have to put 2x plus 2 and y is in the top two.
Good. Wherever I had a y in the top equation, I'm going to put that stuff, right? So I end up with the equation on the top. And we won't do this one because we just did one like this, but it'd be 3x plus 3 times the quantity, 2x plus 2 equals negative 21. And then you're off to the races, right? That's not a big deal. Okay. So what about, scoot down a little bit. Okay, so now if we're using elimination, let's pick a little harder one. How about one like this? We'll pick a hard one. If we can do a hard one, we can do any of them. Then I'll let you go work on this stuff. Okay, so what about that one? Now if I'm going to use elimination, remember, that's not the one where we substitute. That's the one where we want to try to get these, we want to try to get some variables, either the x's or the y's, lined up vertically to cancel, right? So let's grab this one and put it on the other page and try this one. Okay, so what do you think? Which one are we going to want to cancel here? And probably the y's, I guess, right? Okay, y's seem like they're easier to deal with. So to get the y's to cancel, you got to think about two things here. Then what if I have to multiply? In this case, both equations by something, don't I? Because I can't multiply 4 by anything to get 5, and I can't multiply 5 by anything to get 4, right? So I got to multiply both of them. Well, what's the smallest number I could get that both 4 and 5 would go into? 20. So to get that then, what am I going to multiply the top equation by?
4.
Okay. And what's that going to give me if I distribute that all the way through? Okay, negative 100x plus 20y equals negative 80. Okay. Now, what about the bottom equation? What am I going to multiply that one by to get my negative 20y on the bottom? Okay, what's that going to give me? 100x equals 80. Okay, so this was one of those oddball cases when I add them up. Yeah, sure, the y's cancel, but so do the x's and so do the constants. And so I end up getting 0 equals 0. I don't think these were actually even working, but what should the answer be? It should be IM, right? Because that's always true, so we get an infinite number of answers. Now, on a different problem, we would have probably gotten something like y equals 5 or something, right? What would we have done, hypothetically speaking, what if we had gotten this? What if we got y equals 2? How would I find x?
plug two to one.
Yes, I would plug it into one of those equations, maybe the bottom one, for example, and then solve for x. Okay? All right, let's see if this one works. I have a sneaking suspicion it's not going to, but we'll try it. I don't know, were these working? Anybody know? No, it should have though, shouldn't it? Right. So that's, that's why we're not going to use these anymore for a while, because they're not recognizing correct answers right now. Okay, does that make sense?
Yeah.
Okay, let's try, let's see what lab we're in. Let you work on these a bit. I think 205 is open. Let's try that one.